Hello, everyone. My name is Ian Wang. I'm a research associate at Exertion GameStep within the Faculty of Information Technology at Monash University in Australia. I'm glad to be here to share our work on GustosonicSense towards understanding the design of playful gustosonic eating experiences. We all know that eating and drinking are essential aspects to our lives. It is something we do every day, and for most people, it's pleasurable and an enjoyable experience. Additionally, eating often forms a part of our social interactions, whether with our friends, families, or during our solitary moments. When we eat food and drink, we can hear different types of sounds. So we are surrounded by sounds. Here are some examples. This is a sprinkling water sounds. And this is a person chewing apple sounds. We can see that these sounds play an important role in our eating experiences. These sounds allowed us to perceive different food and drinks, and can even influence how we perceive food flavors and our ways to eat and drink. So this kind of sensory experiences between sounds and eating actions, we call it gustosonic experiences. As interactive technology becomes more prevalent in our daily lives, it's increasingly entered to the eating space, even the food space. Given that eating is associated with a lot of pleasure and enjoyment, we believe it is necessary to focus on designing technology that advantage our experiential aspects of eating, rather than just functional-based solutions related to food or drinks experience. In response to this argument, we introduced GustosonicSense, an interactive, playful eating system. Our system utilized wireless earbuds to sense various eating actions through embedded a machine learning model, and triggers a playful sounds to facilitate enjoyable eating and drinking experiences. The system is designed for mobile use, leveraging the ubiquity of earbuds for seamless integration into our daily routines. GustosonicSense consists of a wireless earbuds equipped with a neural measurement unit containing accelerometers, gyroscopes, and a microphone. The IMU detects temporal muscle movements during eating and drinking, while a machine learning model recognizes specific mouth activities. When users wear the earbuds, they can wirelessly communicate with our customized mobile application, which analyzes the IMU data and steaming corresponding sounds back to the user during eating and drinking moments. In developing our system, we considered 4 key design considerations. Firstly, we categorized 5 mouth activities. 3 of them were based on the different types of food texture, including hard food, soft food, and beverages. We identified speaking as a first mouth activity and idleness as a fifth mouth activity to demonstrate that the earbuds can be used in various everyday settings. Secondly, we select 3 sets of sound samples to match 3 mouth activity categories. Thirdly, we collect a database of mouth activity for 6 users to analyze diversity and frequency composition, training a machine learning model to recognize and predict eating activities. Fourthly, we developed a mobile application to facilitate data streaming to and from the earbuds, playing appropriate sound clips based on the prediction results. To understand the user experience of GustosonicSense, we conduct an in-wide study with 6 participants. Each participant used the system during at least 3 meals or snack time over a day study period. will allow our users to freely eat and drink in any location at any time they choose. Then we conduct a semi-structured interview with each participant to understand how they use our system and how they're fitting and how they experience our system. Lately, we used an inductive semantic analysis approach to identify 3 high-level themes and 12 findings in our study. Now we present 3 high-level themes: stimulation, hedonism, reflexivity. In terms of limited time, we brief some findings in our paper in this presentation. If you want more details and information, please reach out to our full paper. In our study, our participants report that they enjoy the GustosonicSense experience and report upon hearing the sounds excitement, which appeared to stimulate them in positive manner. We found that participants appreciate how playful sounds enrich their eating experiences, even though the sound doesn't match what they expect food to sound like. For example, one participant enjoyed chewing pumpkins accompanied by pleasant piano notes. So our finding is now matching sounds stimulating taste experience. Regarding the hedonism, all participants report that they feel pleasure because of the engaging with the system while eating and drinking. Participants report that our system supported them in indulging themselves with eating alone. They all agree that our system wouldn't serve as any additional data partner for sharing food or dishes, but they found pleasure in playful sounds while eating alone. Additionally, all participants agree that the use of a screen distracts them from their food and limited any opportunities to gain pleasure through food. So they also reported that they appreciate being self-indulgent without screen distractions while eating in our study. We also discovered that sounds could influence participant perception of food. Our system appeared to encourage participants to explore their eating action to trigger specific sounds, but the sounds they hear also influence their eating behaviors. Since our system allowed people to eat and drink in any way they want, participants engaged in independent eating activities. For example, a participant transitioned from tasting to chewing pastry upon hearing the crunchy sounds. So they really enjoyed the crunchy sounds, so they reported that they cannot stop eating with those crunchy chip sounds. Based on the results of our study, we present 3 design implications for designers. Firstly, we recommend designers to employ unobtrusive technology for meaningful eating. Obtrusive sensing can enhance the comfort of using digital technology for continuous experience and increase in the recognition process in everyday life. In our work, we utilized the earbuds that provide users with an intuitive eating experience associated with sounds. Participants were able to engage in gustosonic interactions that do not require period knowledge or learning a technical system, facilitating an immediately surprise and the taste exploration. Secondly, we recommend designers to embrace incongruency as a design resource when developing technology related to eating. This is because incongruent feedback can evoke user curiosities and surprises, leading to heightened awareness of their food choice and eating behaviors, ultimately promoting mindfulness and positive eating habits. Thirdly, we recommend designers to consider human values underlying gustosonic experiences. By leveraging machine learning models or generative AI technology in the future, designers could create eating systems that adapt to individual preferences and cultural norms, fostering a personalization and possibly a sense of connection with those intelligent systems. So in conclusion here, we hope our work will assist designers and researchers in developing playful experience around food and beverages, benefiting practitioners in the food and beverages industry who are interested in incorporating interactive technology into their practices and services. So our take-home message is that considering human values in designing interactive eating technology, particularly when integrating any machine learning models in designing future intelligent eating systems. So we believe that designing interactive technology presents a novel opportunity to deeply align with human values, making eating more than just a physical necessary, but an enriched and a pleasurable experience. Thank you for your watching.